What's up, Joe Gamers? Today, special request from Mattkaung. He asked to make a Kojcademy video about derivative and L hospital. To first understand what L hospital is, you need to know what a derivative is, okay? So, a derivative is denoted like this. It's like this. This is its definition form. It is the limit of a function, and it function. Yeah, it as a derivative is an equation that tells you the rate of change or the slope of a certain point on a graph. In the graph here, this is y equals x squared. The derivative of x squared would be 2x, because at any point, let's say this is 1, 2, 3. If this was 1, the slope of 1, the instantaneous slope, the tangent line of y equals x squared at 1 would equal to 2x. This would be y equals 2x. But don't mistake it with this 2x. At 2, the equation, the slope of the line at 2 would be y equals 4x. And then at 3, it'd be y equals 6x. And we see the rate of change of the slopes in each line is 2. So therefore, the derivative is 2x. Now you can obviously prove this by using limits. Limit h approaching 0. And then we put x squared, so x plus h squared minus x squared over h. And then you plug in 1. So, you can go really close. If you squeeze theorem, you can do it on this limit, and you'll get 2. And then so I don't have to prove this to you, little bro. I really don't. I don't gotta prove this to you. But you can find this. You can find a derivative by using rules. Okay. But these rules are like, you get them for doing super cool algebra. Here are the main rules of a derivative that we're gonna be talking about mostly the power rule and chain rule, because that's what's on the Delta Math, little bro. These are the main rules, formulas that we're gonna be talking about today. These rules can be explained another day, or maybe these rules, and maybe this one. But yeah, these are the main rules. Copy them down. Understand what they are, because I'll explain each of them. Okay. So, first one, power rule. Let's say we have a function of x that's equal to x to the n. What does that mean? N is any real number. So, it could be x 1/2, x to the 3, -3, x to the 6, whatever. What the rule states is that if you want to find the derivative of f of x, which is denoted by putting apostrophe right next to the x, you will need to minus the number here and put that number in the front. So the derivative of x to the 6 would be 6x to the 5th. It's really simple. And if it was a fraction or a negative number, you still do the same. So x to the -1/2, well, you do -1, and then it will be x to the -3/2, which would be -1/2 x 3/2. And since the negative, it would be like -1/2 2 3/2. I mean x. Yeah. Okay. Next rule, chain rule. Let's say you have a function like let's say you had a function like 6x squared plus 2x cubed, squared, what the hell am I saying, to the 6. Now, first of all, I'll talk about the sum rule, sum formula, and then it'll correlate to this one. So, let's just focus on the 6x squared plus 2x. What this is saying is that two functions, 6x cubed plus 2x squared, this is f of x, this is g of x. If they're adding, to find a derivative of them, you would just find the derivative and add them together. And we know the derivative, we can find it using the power rule. So this is 18x squared plus 4x. But then, wait, there's a 6 here. So how do we find it? We're not done yet. We're not done here, buddy. So, excuse me. So there that is. Right there. If we see the chain rule, if we use the chain rule, we have to realize that the f of x and g of x in here aren't exactly the same. If we instead made this equation, 6x squared plus 2x squared, whatever, equal u, then it would be u to the 6. And u to the 6, well, we can use chain rule, that'd be 6u to the 5th. But we know u as this, so we would plug that in. 6x squared plus 2x squared cubed that to the 5th. And then, so what we just did was this f of x part, where the u to the 6 was the derivative of the 6u5 is the derivative of this, of the inner part, the outside the parentheses. And then since there's a g of x inside of this function, we plug it back in as normal, because this is a normal g of x, or just this function as a whole. And then we'd multiply it by g prime x. G prime, or g of x, is just u. So u derivative is this. So you just multiply them as so. So let's multiply. So the answer to this would be 18x squared plus 4x times 6 times 6x cubed plus 2x squared to the 5th. And that's basically it. You probably want to label out what function is what, as like you can say this equals u and make it a whole new function, like u of x. Let's say we make u of x equals 6x cubed plus 2x squared, right? Now, if we use chain rule, or actually, I'll just make it g of x. We use chain rule. This is f of x, but f of x is really just g of x to the 6, right? So, we would use the prime f of whatever, and since g of x of 6 is f of x, the f of prime would be 6 g of x to the 5th, right? And then times g prime is 18x squared plus whatever. So multiply 18x squared plus 4x. And then plug that in, that's 6x cubed plus 2x squared, 5th, and then whatever. That's basically how it goes. Now, some of you may be asking, what if the function is not to a power? What if it was 1 over x? Or maybe it was a trig function. Well, for that, you're probably gonna have to search that up or find it yourself, use a derivative, and derive the derivative yourself. But I know you're not doing that, so you're just gonna have to search it up. For example, let's say this right here. F of x equals 6 times sin x squared plus 3 to the power of 3. Basically, you would think you use power rule right here, but since there's a sign being powered, so you can't use the power rule. Only if you were to use the chain rule and then use this would be g prime, this would be g of x, and you'd use that to use the power rule here. And also, by the way, the derivative notation would usually look like this, and there's a x or whatever variable there's gonna be. It could be a t, y, whatever, as long as it's consistent with the variables above it, which is right here. You'd put like a function f of x or x squared, whatever. If there's a constant inside the derivative, it turns into 0, no matter what. Or if it's like a y, so it's a variable, not this, it'll also turn into 0. So basically, if you were to find a derivative of this, you would use the chain rule, use the constant multiple formula, which is the 6 right here, and you use also the product rule right here. And I'm not gonna explain that one because it's gonna take too much time. I'm too lazy. So, Mattkaung, if you're doing this, if you tell me the derivatives of this function, you get like something. I don't know. You can find out how to do it yourself. By the way, I'll give you a hint. Derivative of sine is cosine, but just sine, not sine cubed. You're probably gonna use product rule to find sine cubed, anyways. Alright, so Matt, I want you to do that problem I just showed earlier. And I'll give you like money or something. Or maybe something else, who knows. But for now, we're gonna be talking about El Hospital is a limit. A limit. Let's just put arbitrary numbers here. Let's say that arbitrary function limit. This is a bad example, but whatever. And let's say f of x of f of 0 equals 0, and 0 is x. This is, and then the limit of 0 over 0. This is called indeterminate form. Or There's another one you're gonna see, you might see, but probably not. It's infinity over infinity. This indeterminate form is where you use El Hospital.
New day. Uh, I found out La Papado, and what I was saying was that when a limit is at an indeterminate form, you use La Patal, and what that means is, hold on. Okay, so let's say you had this limit, right? And if you plug in 3, you would get 3 minus 3 equals 0. And then 3 to the square power is 9 times 3 is 27. 27 is 0. And that is not an answer you need to get. So, you use l'hospital, which basically means get the derivative of both this side and this side of the fraction from top and bottom. So, you do d over dx of this, and then d over dx of this. These are their only individual derivatives. It's not, you don't get the derivative of the whole fraction. Anyways, x minus 3, x to the first power minus 1 is 0, and therefore it's 1. This is negative 3 is a constant, so it turns into 0. And then over here, 2 minus 1, use the power rule, and then 2 times 3 is 6x, and this is a constant, so you get rid of that. So the answer to this would just be 6x. Is 6x. Bro. Yo. The limit. Yeah. Yeah, then once you get the derivative of this, you plug in back to 3. You get 3 times the 18. So the answer was the limit of x approaching 3 was 18 because you got the L'Hopital sigma right here. And this number, just 6x, signifies at what point does the slope of the point at 3 reach. So you just put 3 back to get 18 because you're a sigma. Alright, so let's review. Derivatives are an equation that gives you the equation of the tangent line at a certain point at every certain point. So let's say if it's probably equal g of x. Oh, nah, I'm kidding. It's probably equal f of prime x, right? And if I put in f of a here and give me some b, if I put in f prime a, you know what I get? I'll probably get the limit of x approaching a f of x plus a minus f of x. Yeah, or maybe it was 0. Wait, maybe it was 0. Hold on. Yo, my bad. It was x approaching 0. That's a plus h. A over h. Yeah, yeah. What this means is it's giving you the tangent line of a certain point in the graph. Yeah. And L'Hopital is getting the derivative of both sides of a fraction in a limit that's indeterminate form. See d over dx on both sides. On both. And then that equation will give you the tangent line below the they give you the equation for the change in changing lines, and then you plug it in, plug the number of the limit in, and you get the limit, which the limiter already was trying to get, that instantaneous change. With the sigma. I'll make another video another day if this didn't help. That was a little too sick.